Hello. Today we're going to take Notes 3 called Introduction to Proportional Relationships. We have been talking about rates and unit rates so far in our new topic, and we learned that a rate is a comparison of two things. A unit rate is when you're comparing in the denominator as one, like miles per hour, how many miles you can drive in 1 hour, or the unit price, how much, if 10 pineapples cost $15, then you can figure out how much one pineapple costs. Today we're going to dig a little bit deeper in proportional relationships. Here is the definition of a proportional relationship. Again, in your notebooks, make sure you have notes 3 at the top and the title so you can refer back to these if you have questions. The definition of a proportional relationship is when all ratios that are related are equivalent. So when all the ratios that relate the quantities are equal, that's another way of saying that. We're looking for two ratios, and we just talked about ratios in our last notes. Ratios are when you're comparing two things, and you normally write it as a fraction. Sometimes you can write it as a colon. Sometimes you can write it with the word two. But it's a proportion when they're equal to each other. That's what this is saying. When they're equal, then it's a proportion. And we know that 6/8 can simplify to be 3/4 if we divide both of these by 2. And so we know, yes, these are equal, which means they form a proportion. And we can use proportions to help us solve a lot of different problems. If we had the 4 missing, we would be able to, given the numerator as a 3, we would be able to figure out the missing number. That's what we're going to be working on quite a bit. Before we learn how to solve a proportion and use a proportion to help us solve word problems, we need to be able to identify if something is proportional or not. And so the way we do that, the way we check to see if something is proportional, is by looking for something called the constant of proportionality. That's a super long word. But the constant of proportionality is what we're going to do to check to see if a relationship is proportional. There's a formula for the constant of proportionality, and because that is just so long, I abbreviate as the COP, constant of proportionality. So the formula for the constant of proportionality, or the COP, is y divided by x. You're going to do the y value divided by the x value to find the constant of proportionality. This is something you need to memorize. This is something that we're going to refer back to a lot. So make sure you have that written down. So we have two tables here, and I want to determine if one of them or both of them are proportional. And like I was saying, the way we do that is we're going to check to see if there's a constant of proportionality. To do that, again, we do y divided by x. So we look at this table. The 2 is the y value, and the x is 1. So 2 divided by 1. 2 divided by 1 is 2. And so then we do the next one. Y is 6. X is 3. 6 divided by 3 is 2. Then we do the next one. 8 divided by 4. Y divided by x is 2. Do you see how these are all the same? When they're the same, we know it is a proportion. This is proportional. This one is proportional because it has the same number. And that same number has a special name. It's called the constant of proportionality. So the constant of proportionality for this first table is 2. Okay, let's check to see if the next table is proportional. Again, we're going to do that by doing y divided by x. Y divided by x tells us if something is proportional. So 2 divided by 1 is 2. 3 divided by 7. Oh, I'm sorry. We do y divided by x. This is 7 divided by 3. 7 divided by 3 is, 2.33 repeating. 4 divided